Okay, next topic is analysis of condensers. Okay, so to analyze the condenser, before that we are going to discuss the sources of air leakage in the condenser. Okay, so now air leakage from the atmosphere, the air will be enters into the condenser from the joints which are connected in the condenser, which are placed in the condenser. Okay, so the air leakage from atmosphere at joint parts were internally under pressure less than atmospheric pressure. So if the pressure inside the condenser is less, then by means of the joints which are having, by means of the joints, the atmospheric air will rush into the condenser. That is the one of the source for leakage in condenser. Okay. Next one is air accompanied with the steam from boiler which enters dissolve in feed water. Okay. So along with the steam, the air also entered into the turbine and it is expanded, entered into the condenser. That is also one of the cause for sources of air leakage in the condenser. Okay. In jet condenser, a little quantity of air accompanies the injection of water in which it is dissolved. Okay. The cooling water is supplied in different forms. In jet condenser, it is placed by means of a spray type. So during spraying of water, some amount of air also may be entered. That is one of the source of air leakage in the jet condenser. Okay. So what is the effect of air leakage in the condenser? Okay. So first one is, due to the entry of air, the thermal efficiency will be lowered and there is an increase in the requirement of cooling water because the air is also heated during the expansion times. Hence, the requirement of cooling water is very high to condense the air also. Okay. Next, the reduction heat transfer. The heat transfer will be reduced. So corrosion may be occurred because the air contains a humidity terms which will cause the corrosion of the pipes. So that is the one of the effect due to the air leakage. Okay. So now how the vacuum is measured. Okay. Generally vacuum is measured in mm of Hg. Okay. The most commonly device used for measuring of vacuum is vacuum gauge. Okay. So for calculation purpose, the reading is corrected with standard barometric reading as 760 mm of Hg, which is an atmospheric pressure reading. Okay. So this is the vacuum page. So here the vacuum gauge consists of two limbs. So first one is torsal vacuum. First one consists of barometric height and second one consists of vacuum. Second limb measures the vacuum. Okay. So now whatever the change in the vacuum pressure and barometric height, that is considered as an absolute pressure. Okay. So here from the condenser shell, it is connected to the vacuum gauge. Condenser shell is connected to the vacuum gauge. So whenever the pressure drop occurs, then there is a rise in the mercury level in the torsal vacuum chamber. Hence, by that taking the reference, we can measure what is the vacuum produced, and that reading is shown in the distal shown by the pointer, that is in vacuum gauge. Okay. So vacuum efficiency. The vacuum efficiency is defined as ratio of actual vacuum to the maximum obtainable vacuum. That is, vacuum efficiency is nothing but actual volume to the absolute maximum obtainable vacuum. That is barometric pressure minus absolute pressure. So this is calculated by means of the reading observed on the tubes, on the glass tubes. Okay. So next, condenser efficiency. The condenser efficiency is defined as ratio between the outlet and inlet temperature of boiling water to the difference between temperature corresponding to the vacuum in the condenser and inlet temperature of cooling water. Okay, so condenser efficiency is defined as ratio of rising temperature of the cooling water. That is, whatever the cooling water supplied, the initial cooling water is temperature is very less, and after leaving the condenser, the temperature is high because the heat was absorbed by the cooling water during the condensation process. Okay, so and next one is temperature of to the absolute of the temperature of the absolute of pressure in the condenser minus initial temperature of the cooling water. Okay, thank you.